Hello everyone. Today I am here with you all with 12th chapter of class 9th maths curriculum, that is HERON'S formula. In our previous classes we have learned about plane figures like your triangles, rectangles, squares, quadrilaterals. We have learned about all these, how to find the perimeter of all these figures, how to find the area of all these figures. So what perimeter is? Perimeter is basically length of the boundary of any of the closed figure. Suppose I am going to say about this figure, this is your pentagon with the 5 sides. If this is your vertex A, this is B, this is C, this is D, and this is E. If I start walking from A to B, then B to C, then C to D, then D to E, and then E to A, then whatsoever the distance I'll be traveling, that will show us the perimeter. If these lengths are in centimeter, suppose this is your 2 centimeter, this is your 3 centimeter, this is your 4 centimeter, this is again your 3 centimeter, and say this is your 2 centimeter. So the perimeter will be your 2 plus 3 plus 4 plus 3 plus 2, and it will be in centimeter because unit over here is your centimeter. So the unit for the perimeter will even be your centimeter. Now what area is? The surface enclosed by any of the closed figure is its area, and the unit of the area is your square units. That means if this is in centimeter, here the length of the sides of the pentagon is in centimeter, so area will be in square centimeter. Area will be your square centimeter. Unit for this will be your square centimeter. So area is always measured in the square of the units, and perimeter is having the same unit what the sides is having. So this is what perimeter is and what area is. Here in this chapter, we will be learning about area of your quadrilaterals, area of your triangles. So what all are the formulas for finding area of a triangle and area of your quadrilaterals using your HERON'S formula? What HERON'S formula is, that we will be learning in this chapter. So first of all, if we are talking about triangle, so we know that triangle is having 3 sides, 3 vertices and 3 angles. This is your triangle, and the area of triangle is given by 1 upon 2 into base into height. This is the formula for finding area of any of the triangle. And what perimeter of a triangle will be? Perimeter will be sum of all the 3 sides. Sum of all the 3 sides will give us the perimeter of triangle. Now this is A, this is B, and this is C. So perimeter will be given by AB plus BC plus AC. This will give us the perimeter of the triangle. And area will be, if we are considering BC as the base, if we are considering this BC as the base, then perpendicular from the vertex A will be the height. Suppose I am going to say that this is your 4 centimeter. BC is your 4 centimeter, and perpendicular from the vertex A, this is your say 5 centimeter. So area of this triangle will be, 1 upon 2 into base is your BC and height is your, suppose this point is your D, then it will be your AD. So it will be 1 upon 2 into 4 into 5. That will give you your 10 centimeter square will be the area. Now suppose instead of BC, if I'll be considering AC as the base, in that case perpendicular from the vertex B on the side AC will be the height. This BE will be the height. So area could even be given by your 1 upon 2 into base we have taken over here is your AC, and in that case your height will be your BE. Similarly, if we will be considering AB as the base, then perpendicular from the vertex C will give us the height. And suppose this is the point F, then area will be 1 upon 2 into base will be your AB and height will be your CF will be the height. So what we can say is area of a triangle is 1 upon 2 into base into corresponding height. Whatsoever the base we are considering, accordingly we will be considering the height also. And in all the 3 cases, your area will be same because it is showing the area of the same triangle only. Now, if your triangle is your equilateral triangle, if it is your equilateral triangle, in that case what will be the area? See over here, we know that the equilateral triangle is the triangle in which all the three sides are of equal measurement. Suppose I am saying this is an equilateral triangle. This is triangle A, B, C, and all the three sides of triangle ABC is your x centimeter or x centimeter or x meter, whatsoever it is. We are assuming that the sides of this equilateral triangle ABC is your x. Now, if this is x, from here, if I'll be considering BC as the base, then from the vertex A, I'll be making a perpendicular on the side BC. Suppose this is your point D. Then area of this triangle, area will be given by 1 upon 2. If BC I am going to consider as the base, then AD will be the height. This will be the height. Now, we know that if it is an equilateral triangle, in that case, if from the vertex A, any of the vertex, I'll be making a perpendicular on the opposite side, then it is going to bisect the side. That means D will be the midpoint of your BC. It is a property of equilateral triangle that we know that if from any of the vertex we are going to draw the perpendicular on the opposite side, then it is going to bisect the side. That means BD will be half of your BC because D is the midpoint of your BC. So what BD will be? BD will be your x by 2. Now we can see that ACD, it is a right angle triangle because AD is the perpendicular. So your ACD triangle will be a right angle triangle. If this is x by 2, this will even be your x by 2. Now in triangle ACD, angle D is your 90 degrees, so it is a right angle triangle. So we can apply Pythagoras theorem. So we can say that square of the hypotenuse will be equivalent to square of base plus square of perpendicular. We can take any as the base and any as the perpendicular. If this is 90 degree, we can take this even as the base and this as the perpendicular, and we can take this as the base and this as the perpendicular. In all the cases, hypotenuse will be your AC only because side opposite to 90 degree is always the hypotenuse. So we will be saying that AC square, that is your hypotenuse, it is equivalent to your CD square plus your AD square. Value of AC we have assumed to be x, so it is your x square. CD will be half of x, that is x by 2, square of that, plus AD square. We have to find the value of AD from here. So it will be your x square equivalent to x by 2 whole square will be your x square by 4. X by 2 into x by 2 will be x square by 4 plus AD square. So what AD square will be? X square, this x square by 4 I am taking in LHS with a negative sign. So it will be the value of your AD square, or we can say 4 will be the LCM. 4x square minus x square is your AD square, or it is your 3x square by 4 is the value of AD square. So if AD square is 3x square by 4, so what the value of AD will be? AD will be square root of 3x square by 4, that will be root of 3, square root of 4 will be 2, and square root of x square will be your x. So this is the value of height AD. Now we have to find the area. So what area will be? Area is 1 upon 2 into base. Base will be your BC we have considered as base. This was the area of an equilateral triangle if we had taken BC as the base. So 1 upon 2 into BC. BC is your x into AD. AD is your root of 3x by 2. So if we will be solving it, root 3, x into x will become your x square and 2 into 2 will become 4. So we will be saying root 3 by 4. X is the side of the equilateral triangle into your side square will be the area of an equilateral triangle. If the side of the equilateral triangle is x, in that case it will be root 3 by 4 into x square. If the side is say 4 centimeter, if the side of an equilateral triangle, if we are assuming it is to be 4 centimeter, in that case its area will be root 3 by 4 into side square means 4 into 4 because side we have assumed to be 4. So 4 into 4, so it will be 4 root 3 centimeter square. So this is how we can find the area of an equilateral triangle. Now, if instead of equilateral triangle, it is an isosceles triangle. If it is an isosceles triangle, so how we can find the area? We know the isosceles triangle is the triangle in which two sides are equal. If this is your triangle A, B, C, in which AB is your x and AC is even x. That means equal sides are your AB and AC are the equal sides and BC is your y centimeter. If these are the dimensions, if these are the measurements of your sides of an isosceles triangle, in that case, how we can find the area of this isosceles triangle? So we know that the area of isosceles triangle, again the formula for finding area of any of the triangle will be your 1 upon 2 into base into height. Now if we have to find the perimeter of this, perimeter will be your sum of all the three sides, that is your x plus y, that is 2x plus y will be the perimeter. Similarly, perimeter of an equilateral triangle will be, perimeter will be sum of all the three sides, because all the three sides are of equal measurement. So it will be x plus x, or we can say 3x, or we can say 3 multiplied by its side. This will be the perimeter. Now coming back to your isosceles triangle, for the isosceles triangle we know that two sides are of equal measurement. Now if from the vertex A we will be drawing a perpendicular on the side BC, then again it is going to bisect the side BC. It is even the property of an isosceles triangle, but it is not the case in the scalene triangle. So here in the isosceles triangle, again from the vertex A we have made a perpendicular on the side BC. Suppose this is intersecting the side BC at the point D. So area of this triangle will be 1 upon 2 into base into height. We know the area of triangle is this only, 1 upon 2 into base into height. So base over here is your, if BC we have taken as base, so it will be 1 upon 2 into BC into your AD. This will be the area. Now we have to find the side AD, that means perpendicular AD we have to find. How we can find again? Again we know that ABC triangle, it is an right angle triangle. So we can apply the Pythagoras theorem in the triangle, in triangle ADC. We know that the hypotenuse will be your AC square will be equivalent to your DC square plus AD square. That is, hypotenuse square will be sum of the squares of the rest two sides. It is your Pythagoras theorem. Now again we are saying that D is bisecting the side BC. That means your DC will be y by 2. DC will be half of your BC. That is, value of DC will be your y by 2. So in this triangle ADC, we can say AC square, that is your x square. It is equivalent to DC square, that is your y by 2 square plus AD square. So we can say x square. This square of y by 2 whole square will be your y square by 4. I am taking it in the LHS, so it will become minus of y square by 4. It is the value of your AD square. So what the value of AD will be? AD will be square root of x square minus y square by 4. So if we will be solving it further, 4 will be the LCM. It will become 4x square minus y square. Square root of 4 we know it is your 2. So it could even be written as 1 upon 2, or we can say in the numerator it will be 4x square minus of y square, and in the denominator without the square root sign it will be your 2. This is the value of your AD, that is your perpendicular, or we can say the height. Now the area just now we have seen that area of this triangle will be 1 upon 2 into BC into AD. So area will be 1 upon 2 into base is BC, that is your y, into AD. Just now we have seen that the value of AD is 1 upon 2 into numerator part is your 4x square minus y square. This is the value of the height AD. So if we will be solving it further, numerator over here it is y, over 2 multiplied by 2 will be your 4, and it is multiplied by your root of 4x square minus y square. Over here x is the side which is equal, means equal sides we have taken as x and y we have taken as an unequal side, or the base we have taken as y. So area of an isosceles triangle will be given by your y by 4 multiplied by your 4x square minus y square. Over here x is the equal sides of an isosceles triangle and y is your unequal side. So if we say that the equal sides, that means value of x is say 4 centimeter and value of y is say 6 centimeter. So what will be the area of an isosceles triangle? So if we will be solving it, it will be, instead of y we will be keeping 6 by 4 multiplied by 4 into x square. X is your 4, so square of 4 minus y is your 6, so square of 6. So it will be 2 3s are 6, 2 2s are 4, 3 by 2 and square root of 4 4 is 16 and 16 4 is 64. Minus of 6 6 is 36. So we will be solving it further, we will be getting its value. It will be 14 minus 6, 8 and it is 5, 28. So we will be solving it further and we will be getting its value. So it will be your this much of centimeter square will be the area of an isosceles triangle if it's one of the side which is equal side is your 4 centimeter and unequal side is your 6 centimeter. Just now we have seen how to find the perimeter and area of an equilateral triangle and isosceles triangle. Now let's see how we can find the area of scalene triangle. We know that the scalene triangle is a triangle in which all the three sides are of different measurement. If ABC is a scalene triangle with one of its side as A, another side as your B and the third side is your C, that means all the three sides are of different measurement, then how we can find the area of this type of triangle? In the case of equilateral triangle and isosceles triangle, it was very easy to find the height. If we are taking any of the side as the base, so it was very easy to find the height of that particular triangle. That means for that corresponding base, we can find the height in the case of equilateral triangle also and in the case of isosceles triangle also. But here in the case of scalene triangle, it is very difficult to find the height of this triangle. So these type of triangles, we are having a special formula that is known as HERON'S formula. Using HERON'S formula, we can find the area of these type of triangles also. This HERON'S formula is applicable for all type of triangles. That means this is applicable for your equilateral triangle also. It is applicable for your isosceles triangle also. It is applicable for your scalene triangle also. Using HERON'S formula, we can find area of any type of triangle. So according to HERON'S formula, first of the term which we use is your semi-perimeter. Semi-perimeter is the term which we use. It is denoted by your S. We know that the perimeter will be given by your sum of all the three sides. Perimeter of the triangle ABC will be sum of all the three sides, that is your A plus B plus C. So semi-perimeter S will be half of your perimeter. That means value of S will be A plus B plus C by 2. This is your S, which is the semi-perimeter. Now area of the triangle will be given by square root of S, S minus A, S minus B and S minus C. This is how, using this formula, we can find the area of any of the triangle. Here A, B, C are the three different sides of your scalene triangle. It could be your same also. In the case of equilateral triangle, all ABC will be same. In the case of isosceles triangle, two of them will be same. And in the case of scalene triangle, all these three will be different. So using this formula, we can find area of any of the triangle. Now see, what we have done is, first of all, we have found the perimeter of the triangle. Then semi-perimeter S is given by your A plus B plus C by 2. That means perimeter divided by 2. Then formula for finding area will be square root of S, that is your semi-perimeter, multiplied by S minus A, multiplied by S minus B, multiplied by S minus C. We will be seeing in this video only how we can use this formula and how we can find the area of the triangles. So this is how we can find area of any of the triangle, and this formula is known as HERON'S formula. This is your HERON'S formula. Very important formula it is. Now this is how we can find the area of any of the triangle. Now let's come to your right angle triangle. If it is your right angle triangle. If it is a right angle triangle, that means one of the angle will be on 90 degree. If this is your triangle A, B, C, in which this is your say A centimeter or meter, or this is your B and this is your C. Over here angle B is your 90 degree. In that case, in the type of your right angle triangle, we can take either this as the base and this as the perpendicular or the height, or if we will be taking AB as the base, in that case we will be considering BC as the height. So perimeter will be given by sum of all the three sides. Perimeter will be given by sum of all the three sides, and area will be given by 1 upon 2 into, if we are considering BC as the base, in that case your AB will be the height, that is your AB. And if we will be considering AB as the base, in that case your BC will be the height. So in any case, area of a right angle triangle will be 1 upon 2 into A into B, if this is your A and this is your B. This is how we can find the area of a right angle triangle. Now if it is an isosceles right angle triangle, if it is an isosceles right angle triangle. So we know isosceles right angle triangle, in this is your A, this is your B, this is your C, and this angle is your 90 degree. This way AC will be the hypotenuse, which will be the side opposite to 90 degree. In this case your AB and BC both will be equal, because it is an isosceles right angle triangle. That means two of the sides will be equal. That will be AB will be equivalent to your BC. So if this is your A, this will even be your A, and suppose this is your B. So the base and your height will be equal. If we will be considering BC as the base, so AB will be the height. If we will be considering AB as the base, in that case BC will be the height. So perimeter will be given by, perimeter will be A plus B. Sum of all the sides will be the perimeter, or we can say 2 times of A plus B, and area will be given by 1 upon 2 into base into height, that is A square by 2. So this is how we can find the area of various type of triangles. Now if we are talking about quadrilaterals, how we can find the area of quadrilaterals? We know what quadrilateral is. Quadrilaterals are your four-sided polygons. So quadrilateral, what we could do in quadrilateral, suppose this is a quadrilateral, then if we will be making any of the diagonal, suppose this is your A, B, C, D, and if we are having all the four sides and the measurement of your diagonal even, in that case we can see over here that this quadrilateral is divided into two triangles. This is your first triangle, this is your second triangle, and if we can find the area of first triangle and second triangle, we can add these two areas, and that will give you the area of the quadrilateral ABCD. Just now we have seen that using Heron's formula, if all the three sides are of different measurement, we can find the area of the triangle. So if we are having the measurement of AB, AD and BD, then using Heron's formula, we can find the area of triangle ABD. Similarly, if we are having the values of BC, CD and BD, we can find the area of triangle BCD also using your Heron's formula. Whatsoever the area we will be getting from this triangle and whatsoever the area we are getting from this triangle, if we will be adding these two triangles, then it will be giving us the area of the quadrilateral of ABCD. How we will be using this concept, that also we will be studying in this video only. Now coming to your rectangle. We know what rectangle is. Rectangle is a parallelogram in which all the angles are 90 degree and opposite sides are equal. So if this is your L, so this will even be your L because opposite sides are equal in the case of rectangle. And if this is your B, this will even be your B. So perimeter will be given by, perimeter will be L plus B plus L plus B. This is what perimeter will be, length of the boundary, L plus B plus L plus B, or we can say 2L plus 2B, or we can say 2 into L plus B. This is the formula for finding perimeter of a rectangle. Now what will be the area? We have learned in our previous classes that area of a rectangle is given by L into B, length multiplied by its width. If we are going to multiply these two, it will give us the area of a rectangle. Now coming to square, we know square is even a parallelogram only in which all the four sides are equal and all the four angles are your 90 degree. It is a square. So what the perimeter will be if this side is your A. So all the sides will be your A only. A. If this is your A, B, C, D, then all the sides are of A. Then your perimeter will be given by sum of all the sides, that is A plus A plus A plus A. That is your 4 times of A. It will be the perimeter of the square. And what will be the area of the square? It will be A multiplied by A. That is your side square. This will be the area of your square. So this is how these are the formulas using which we can find the area of your scalene triangle, your right angle triangle, your isosceles right angle triangle, quadrilateral, rectangle, your square. We'll be learning for other your quadrilaterals also, like your trapezium, like your parallelogram. All these even we'll be learning, and then we'll be solving the questions based on the chapter. Now let's understand how we can find the area of some specific type of quadrilaterals. So coming to your parallelogram. So we know that the parallelogram is a quadrilateral in which opposite side, both the pair of opposite sides are parallel. If this ABCD is a parallelogram, in that case AB will be parallel to your CD and your AD will be parallel to your BC. If both the pair of opposite sides are parallel to each other, then we say the quadrilateral to be parallelogram. And if in this case your both the pair of opposite sides are equal also. So if this is A, this will even be A. If this is B, this will even be your B. And from here, if you will be making a perpendicular on the side your DC, suppose this is your point E. In that case, perimeter will be, we know the boundary, the total length of the boundary is the perimeter. So it will be A plus B plus A plus B will be the perimeter. A plus B plus A plus B, that means 2 times of A plus 2 times of B, or we can say 2 times of A plus B will be the perimeter of a parallelogram. What the area will be? Area of a parallelogram is given by base into height. Base into height. So if we are considering DC as the base, and in that case your corresponding height will be your AE, so it will be your base is your A and height over here, suppose it is given by your small h, so it is your h. So if we will be considering DC as the base, this will be the height, and if we will be considering BC as the base, so from here we will be making a perpendicular on the side BC and that will be the height. So similarly, accordingly, whatsoever the base we are considering, accordingly corresponding height we will be considering. So this is the area of your parallelogram. Now coming to your rhombus. So what rhombus is? Rhombus is even a special type of parallelogram only in which all the four sides are equal. But angles are not 90 degree as in the case of your square. So if ABCD is a rhombus, all the four sides will be of equal measurement. If it is A, all will be A only. And these are the diagonals. A, C and your BD are the diagonals. Suppose your AC is your diagonal D1 and BD is your diagonal D2. This is the measurement. D1 is the measurement of the side your diagonal AC and D2 is the measurement of the diagonal BD. So the perimeter will be total length of the boundary, that is A plus A plus A plus A. We will be saying 4 times of its side will be the perimeter of a rhombus. And its area will be 1 upon 2 into D1 into D2. Length of the diagonal first into length of the diagonal second divided by 2 will be the area of rhombus. D1 is the measurement of first diagonal and D2 is the measurement of the another diagonal. Means we will be multiplying product of both the diagonals divided by 2 will give us the rhombus, area of the rhombus. And the special property of rhombus is that these angles, that the diagonals are bisecting each other at 90 degree. They are perpendicular bisectors. Now coming to your trapezium. Trapezium. Trapezium is a quadrilateral in which one pair of opposite side is equal, not equal, parallel. So if this is ABCD, so AB will be parallel to your CD. The another pair of opposite side is not parallel to each other, but only one pair of opposite side is parallel in the case of your trapezium. Over here, AB is parallel to your CD. If this is your A, this is your B, this is your C, and this is your D. In that case, we know the perimeter will be sum of all the sides, that is A plus B plus C plus D. And from the vertex A, if we are making a perpendicular on the side CD, and suppose it is your point E, and this AE, which is the height of this trapezium, this is denoted by your small h. So perimeter will be given by A plus B plus C plus D, and area will be 1 upon 2 into height into sum of parallel sides. The sides which are parallel, we will be adding these two sides. So it will be given by 1 upon 2 into h into parallel sides here A and B. So A plus B. This will be the area of trapezium, 1 upon 2 into height into sum of parallel sides. This is how we can find the area of your trapezium. If your non-parallel sides like BC and AD are equal, then we say trapezium to be an isosceles trapezium. Now coming to your cyclic quadrilaterals. Cyclic quadrilaterals. In the chapter circles, we have learnt about it. So what cyclic quadrilaterals are? Cyclic quadrilaterals are the quadrilaterals whose all the four vertices lie on the circumference of a circle. If A, B, C, D is a quadrilateral, then it is known as your cyclic quadrilateral because all the four vertices of the quadrilateral lie on the circumference of a circle. So these type of quadrilaterals are known as your cyclic quadrilaterals. The property of cyclic quadrilaterals is that opposite angles, sum of opposite angle is your 180 degree. Angle A plus angle C will be 180 degree. Angle B plus angle D will be your 180 degree. This is the property of your cyclic quadrilateral. So if we are taking the sides to be your A, B, C and D, these are the four sides of a cyclic quadrilateral, then your perimeter will be given by your A plus B plus C plus D. This will be the perimeter of the cyclic quadrilateral. So semi-perimeter will be A plus B plus C plus D by 2. This will be the semi-perimeter of your cyclic quadrilateral. In that case, area is given by root of S, S minus A, S minus B, S minus C and S minus D. This is the formula using which we can find the area of any of the cyclic quadrilateral. The specific property of a cyclic quadrilateral is that opposite angles, sum of the opposite angles is your 180 degree. So if it is a cyclic quadrilateral, using this formula, we can find the area of any of the cyclic quadrilateral. Now see, we can see over here that square is even a cyclic quadrilateral, your rectangle is even a cyclic quadrilateral, and your isosceles trapezium is also a cyclic quadrilateral because in all these three, your sum of opposite angles is your 180 degree. So all these are your cyclic quadrilateral, and using this formula, we can find the area of a cyclic quadrilateral. Now let's see how we can use these formulas whatsoever we have learned till now in solving the problems. Let's take some questions from your exercise 12.1. We are taking question number 4, exercise 12.1, question number 4 we are taking. Find the area of a triangle, two sides of which are 18 centimeter and 10 centimeter, and the perimeter is 42 centimeter. So one of the triangle is given to us. Suppose this is your triangle A, B and C. One of the side is given to us as 18 centimeter. Another side is given to us as your 10 centimeter. And perimeter is given to us as 42 centimeter. we are assuming that the third side, suppose this third side AC is your x centimeter. So we know the perimeter of any of the triangle will be sum of all the three sides. So perimeter is given by your 18 centimeter, that is your AB, plus BC plus your AC. Sum of all the three sides will give us the perimeter of the triangle. So it is equivalent to your 42 centimeter given to us in the question. AB is 18, BC is 10, and we have assumed AC to be x. So it will be 42 equivalent to 18 plus 10 will be your 28 plus x. So 42 minus 28 will be the value of your x. So what x will be your? It will be 14 centimeter will be the value of your x. That means your side AC will be 14 centimeter. Now, how we can find the area of this triangle? We know the area of the triangle is given by your root of s, s minus a, s minus b, s minus c. This is the formula for finding area of an scalene triangle or any of the triangle, we can say. Over here we can see that a is one of the side, that is 18 suppose, b is your say another side, that is 10, and c is the third side, that is your 14. So what we will be doing is, first of all, we need to find the semi-perimeter. Over here, perimeter is given to us equivalent to your 42. So semi-perimeter will be perimeter divided by 2, that is 42 divided by 2. 21 will be the semi-perimeter value of S. Now area will be, area is root of S. S is your 21. Then 21 minus A is 18. 21 minus B is 10. And 21 minus C is your 14. We will be solving it further. Square root of 21 multiplied by 21 minus 18 will be your 3. 21 minus 10 will be your 11. And 21 minus 14 will be your 7. Now we will be solving it further. We will factorize all the terms, all the numbers will be factorizing. 21 could be written as 3 multiplied by 7. This is 3, cannot be further factorized. 11 further cannot be factorized, and this is 7. Now make the pairs. There is a pair of 3. So 1 3 will come out of the square root sign. 1 7 will come out of the square root sign. And 11 there is no pair, so it will be in the square root sign only. So it will be 3 7 is 21. Root of 11. Unit was your centimeter. So area will be 21 root 11 centimeter square. This is how, using Heron's formula, we can find area of any given triangle. Now let's take question number 5. Sides of a triangle are in the ratio of 12:17 is to 25. And its perimeter is 540 centimeter. Perimeter is 540 centimeter. It is the perimeter. Find its area. We have to find its area. Now we are assuming, suppose this is the triangle ABC, in which the sides we are assuming to be, because it is in the ratio of 12:17 is to 25. This is the ratio of the sides. So we are assuming sides to be 12x, 17x, and your 25x. Suppose these are the sides of the triangle ABC. Suppose we are assuming that this is your 12x, this is your 17x, and this is your 25x. So what the perimeter is? Perimeter is sum of all the three sides. So perimeter will be, and it is equivalent to your 540. It is equivalent to 12x plus 17x plus your 25x. Sum of all the three sides will give us the perimeter of the triangle. So it will be 540 equivalent to 7, 9, 14, 4 carry over 1, 54. It is equivalent to 54x. So what the value of x will be? 540 divided by 54. So it is your 10. So value of x is your 10. Now the sides will be side AB. It is your 12x, that is 12 multiplied by 10. Value of x is 10, that is 120 centimeter. Side BC is your 17x. it is your 17 multiplied by 10, that is 170 centimeter. And side AC is your 25x. So it is 25 multiplied by 10, that is 250 centimeter. So these are the values of all the three sides of a triangle. Suppose this is your A, this is your B, and this is your C. So what the value of S, semi-perimeter S will be? Perimeter divided by 2. Perimeter over here is given to us as 540 divided by 2. So 2 is 4, 2 7 is 14, 270 centimeter will be the value of your S, that is your semi-perimeter. We know the area is given by Heron's formula, that is S, S minus A, S minus B, and S minus C. So we will be keeping all the values. Value of S is your 270 multiplied by S minus A, that is 270 minus A is your 120, 270 minus B is your 170, and 270 minus C is your 250. So we will be solving it further. What the value will be getting? 270 multiplied by 270 minus 120 will be your 150. 270 minus 170 will be your 100. And 270 minus 250 will be your 20. Now we will be solving it further. What we can write it as? 27 could be written as 3 multiplied by 3 multiplied by 3. I am keeping it as 10 only because there are so many 10s are there, so we can make the pair of 10 also. So we have taken as 10 only. So 270 could be written as 3 multiplied by 3 multiplied by 3 multiplied by 10. 150 could be written as 3 multiplied by 5 multiplied by 10 will be 150. 100 could be written as 10 multiplied by 10. And 20 could be written as 2 multiplied by 10. Now make the pairs. Over here we can see it is one pair. We can take it out. Here also one more pair of 3. So we have taken one more 3 out. From these two tens we have taken 1 10 out. From these two tens we have taken 1 10 out. Now what is remaining over here? 1 5 and 1 2. See, 5 multiplied by 2 will be 10 and one more 10 is over here. So 2 tens are there. 5 into 2 is 10 and one more 10. So 1 10 we have taken out. So it will be your 9,000. 3 3s are 9 and 3 more zeros. So 9,000 centimeter square will be the area of the triangle. This is how we can use the concept of Heron's formula. Using Heron's formula, we can find area of the given triangles. Till now, we have seen that how using Heron's formula, we can find area of a triangle. Now, if instead of a triangle, a quadrilateral is given to us, then how using Heron's formula, we can find the area of the quadrilateral. Just now we have learned that we can make a diagonal, and using the diagonal we can divide the quadrilateral into two triangles. And if we are having all the four sides and if we are having the measurement of the diagonal even, we can find the area of both the two triangles using Heron's formula. And once we are having all the areas, both the areas, then we can add these two areas to get the area of the quadrilateral. Now let's see how we can use this concept in finding the area of the quadrilateral. So we are seeing over here some of the questions from your exercise 12.2. Question number 1, we are considering a park is in the shape of a quadrilateral ABCD in which angle C is 90 degree, AB is 9 meter, BC is 12 meter, CD is 5 meter and AD is 8 meter. How much area does it occupy? So first of all, we'll be making the figure. Question number 1. The figure will be this is your A, this is your B, this is your C and this is your D. It is given to you that angle C is your 90 degree. Measurements are your AB is 9 meter, BC is 12 meter, CD is 5 meter and AD is 8 meter. These are the measurements given to us. So we can write it over here even. AB is 9, this is your 9 meter. BC is 12 meter, so this is your 12 meter. CD is 5 meter. and AD is 8 meter. We know that this is your angle, C is 90 degree. So we can make the diagonal BD. Why we have made this diagonal BD? Because we know that in a right angle triangle, we can use the Pythagoras theorem. And if any two sides are given to us, we can find the third side. So over here, we can see the triangle BCD is a right angle triangle because angle C is 90 degree. Over here, we can find the value of the measurement of your BD, that is hypotenuse, using your Pythagoras theorem. So in triangle BCD, hypotenuse square, that is BD square, will be equivalent to BC square plus your CD square. We have applied the Pythagoras theorem. So BD, we have to find its value. BC is 12 and CD is 5. So square of BD will be 12 square is 144 and square of 5 will be 25. That will be your 169. So BD will be square root of 169. That will be your 13 centimeter. It will be. All the units are in meter, so it will be in meter only. We will be ignoring your negative 13 because side cannot be negative. So we will be taking BD as positive 13 meters. Now we are having the value of this diagonal even. Now, using your Heron's formula, we can find the area of this whole quadrilateral. We can convert it into this one triangle and this another second triangle. We will be finding the area of first triangle and second triangle, and we will add these two. We will be getting the area of the quadrilateral ABCD. So, area of the triangle, first of all, area of triangle BCD. Just now we have learned that if it is a right angle triangle, directly we can find the area of the triangle. That is, area of the triangle is given by 1 upon 2 into base into height. So over here, if I'll be considering DC as the base, in that case BC will be the height. So it will be base, if I'm considering 5, so height will be your 12. 2 6 is 12. So it will be 5 6 is 30. It is your meter square. Now, area of the triangle ABD we need to find. We are having all the three sides of it. So, first of all, we are assuming A, first side as 8, B as your 9, and C as your 13. We have found all the three sides of the triangle. That is, your A is 8, B is your 9, and C is your 13. Now, what the semi-perimeter will be? Semi-perimeter will be A plus B plus C by 2. That is 8 plus 9 plus 13 by 2. So it will be 16, 17, 20, 2, 3 by 2. That is your 15 will be the semi-perimeter. Right? Now, if 15 is a semi-perimeter, area will be given by root of S, S minus A, S minus B, S minus C. So, S is your 15. 15 minus A is your 8. 15 minus B is your 9. 15 minus C is your 13. So, this will be 15 multiplied by 15 minus 8 will be your 7. 15 minus 9 will be your 6. 15 minus 13 will be your 2. So, it will be 15 could be written as your 3 multiplied by 5. 7 is as it is only. 6 could be written as 2 multiplied by 3 and 2 we have taken as 2 only. So now one pair of 3. This 3 will come out. One pair of 2 will come out. It is 5, 7 is 35. So it will be 3 multiplied by 2 will be 6. 6 multiplied by root of 35. That much of meter square. If we will be finding its value, we have to find the square root of 35, and square root of 35 will be somewhere, just check it out, 35. We will be solving it. 5 5 is 25. 6 6 is 36. So it will be around your 5.9 something. Approximately 5.9 something, because 6 6 is 36. So if we will be finding the square root of your 35, it will be somewhere near 5.8 or 5.9. So we are considering it to be, suppose it is your 5.9. So 6 multiplied by 5.9, it will be 8 is 48, 9 it is, 9 is 54, 30, 35, 35.4 meter square. And area of triangle, your previous triangle, that is your BCD, that was 30 meter square, and area of triangle your ABD, it is for area of triangle ABD. So area of the quadrilateral, your ABCD will be area of triangle BCD plus area of triangle your ABD. These two triangles area, if we will be adding, we will be getting area of the quadrilateral ABCD. So area of the triangle BCD was your 30 meter square, and area of triangle ABD is your approximately 35.4 meter square. So it will be around 65.4 meter square will be the approximate value of the area of the quadrilateral ABCD. If we will be finding the square root of 35 precisely up to 2 decimal point, we will be getting exact area of your quadrilateral ABCD. Now let's see question number 5 of this exercise. Question number 5. A rhombus shaped field has green grass for 18 cows to graze. If each side of the rhombus is 30 meter and its longest diagonal is 48 meter, how much area of grass field will each cow be getting? So first of all, we are making the rhombus. All the four sides are equal in the rhombus. We know that. If this is the rhombus ABCD, then total sides, all the sides are of 30 meter, so all will be of 30 meter. This is 30 meter, this will be 30 meter, this will be 30 meter, and this will even be your 30 meter. All the sides will be of 30 meter, and the diagonal is your 48 meter. This is your 48 meter, and it is sufficient for 18 cows to graze. So how much area each of the cow will be getting? So we have to find the area of this rhombus ABCD. Now we can see over here that this diagonal BD is dividing the rhombus into two triangles, two congruent triangles, because we know that in a parallelogram, diagonal divides the parallelogram into two congruent triangles, and area of congruent figures or the congruent triangles will even be equal. So if area of this is whatsoever the area of one triangle will be coming, the same will be area for the another triangle even. So now we are having all the four sides even, and we are having the measurement of the diagonal even. Using Heron's formula, easily we can find area of the triangle. So over here, first of all, we are considering this. Suppose your value of A, one of the side is 30, value of B, that is another side is even 30, and value of C, that is third side, is your 48. We are considering triangle BCD. In triangle BCD, we have taken first side as 30, second side as 30, and the third side as your 48. So first of all, we will be finding the semi-perimeter. That will be your sum of all the three sides divided by 2. That will give us 8, 4, 3, 7, 10, 108 divided by 2. That is 54 meter will be your semi-perimeter. Now area is given by root of S minus A, S minus B, S minus C. This will be root of S is your 54. 54 minus A is 30. 54 minus B is 30. 54 minus C is your 48. So we will be solving it further. It will be 54 multiplied by 54 minus 30. It will be 24. 54 minus 30 will be 24. 54 minus 48, 56 it is. So if we will be finding its square root, so 54 could be written as 9 into 6, or we can say 3 into 3 into 6. 54 could be written as 3 3s are 9 and 6 9 is 54. And this is 24 written I am keeping it as it is because there are 224s are there. So we can take 124 out of it. And 6, I am keeping it as it is. Now from one pair of 3, 1 3 will come out of the square root sign. One pair of 6, 1 6 will come out of the square root sign. And one pair of 24, 124 will come out of the square root sign. So what will be the multiplication of these? It will be 6 4 is 24. I'm just taking it 3 as it is. 6 4 is 24. 2 6 2 is 12. 144. Now multiplication of these two will be 4 3s are 12, 2 carry over 1, 4 3 is 12, 13, carry over 1, 3 1 3 and 1 4. 432 meter square will be the area of the triangle BCD, and it will be area of triangle BCD will be equivalent to area of triangle BAD also, and it is equivalent to your 432 meter square. Now area of your ABCD will be area of triangle BCD plus area of triangle BAD. If we will be adding these two areas, we will be getting area of the rhombus ABCD. So it will be your 432 plus 432. That will be 4, 336 and 864 meter square will be the area of your rhombus ABCD. Now this area is sufficient for 18 cows to graze. So how much area one of the cow is getting? So area for one cow, area available for one cow will be 864 divided by 18. And if we will divide 864 by 18, we will be getting 48 meter square. So area which is available for every cow will be on 48 meter square. So this is how, using Heron's formula, we can find areas of various quadrilaterals also. Here we have found the area of a rhombus. Here simply we have taken a quadrilateral. So using Heron's formula, we can find area of any of the triangle also, and area of the any of the quadrilateral also, if we are having all the sides and the diagonal also. So hope it is clear to you how what Heron's formula is, how it is important, how we are using the Heron's formula in solving our day-to-day life problems. Now this is all from this chapter. Soon we'll be coming with more videos on other chapters of class 9th maths curriculum. If you have not yet subscribed my channel, please do subscribe it. Thank you.